All right, so this is a new box I set up for a key and safety scanner. On the outside here we have real basic setup, key on and off, and then some LED status lights. Inside we have a catastrophe. I haven't finished it yet. So basically what we'll have is on a shear, we have a command from a PLC. So on this unit I couldn't set up a e-stop, because if I were to set up an e-stop it stops an entire operation, so we can't do that. So these wires are from Mimic right now, but they are to interrupt a signal, and these are technically my output wires back to the PLC. But as you can see here, 24-volt power supply, safety relay, and 3 other relays. And basically what we have here is, it's unfinished, but in essence the key and scanner will operate the safety relay, and it will allow a bypass, not a bypass, but an active safety through the relays, and allow signal to go through and operate the machine as long as these relays are closed. But in the event that we have to bypass the safety unit, you turn the key switch, these relays change operation, and we're able to bypass the safety system and still allow the unit to operate. But in the event that power is lost, nothing will work. So if everything is not active in here, nothing will work on the safety system. So if power supply goes bad, nothing will work on the shear. And it's pretty simple, but pretty detailed. I do have some things missing in here from the safety relay yet, but let me get the paperwork real quick, and we will check this out. So we have our L1 110 volt into a 5 amp fuse going into a 24 volt power supply, and then out of the power supply we have a 5 amp fuse that is going to power the safety scanner, the safety relay, and then the coils for the relays. So we got here and we are in sheet 1, sheet 2. I just had to hurry up and scribble these. Okay, so power goes through points 6 and 12 in a normally closed relay, in relay 2. So it goes in there. And it goes to the power A1. And then A2 will go to ground off or 0 volt on the 24 volt power supply. So this goes into, actually I'm sorry, yeah, I am right. So this relay goes to the fuse. Fuse goes down to a block. Block powers 24 volts. Okay, 24 volts is going in to the contact, out of the contact, normally closed. Alright, then we're off into 0. Also on the 24 volts, we have block 7, and let's see, that's going to our key switch here, over into block 8, or terminal block 8, key switch on or off. So in the on position, we're going to yellow on the LED. Okay. And we have constant power to relay 3. Normally closed goes to red. That means the system's off. Normally open is going to green. Okay, on relay 2. The coil on relay 2 then goes to green. 24 volts into relay 1, and then gray coming off the safety scanner. 11, control relay 3, coil into block 18, and then also blue is going to our 24 volt. Brown, which is our 0 volt or 24 volt, is going to 13 as well. So as you can see, it's a little messy. I'm using tops and bottoms for power, so I have like power coming in, and I'm sharing a block, which I shouldn't have done. But and we also have power going in here, sharing blocks. Anyways. So we come off sheet 1, which we pointed to sheet 2. So there's terminal block 14 going to 0 volt, and then we're cutting the wire from the PLC, and we're driving in a wire from, we're basically going to call it an input from the PLC to command a servo valve into normally closed control relay 1. So that's the first one, and then safety relay 1 into K1, which will be up there, and then terminal block 19, and then it feeds back into the PLC to control retracted cut. So that's part of another schematic. Now, when control relay 1 opens, we're bypassing. Okay, so that's this one. Second wire, same exact thing, just goes into cut. That's it. So we have safety relay 1 K2, 24, 0.24, 0.22, 9 and 5 on the relay, and that's really really simple. So look at it again. The key switch operates the relays. We're here. So control relay 3, normally closed, feeds red, and then control relay 3, open, controls green. So when these relays open or close, they control the other relays to bypass. This one is specifically just for a light. That's all it is. This one here sends power to the this one sends power to the safety devices and the safety relay, and this is really important. I didn't realize this. So even though this thing, when it powers off, okay, this is really important, when it powers off, if the cans safety scan, if there, well, it doesn't matter what we call it cans, we just call it a cans, but anyways, if the safety scanner still sends in inputs to S11 or S12 and S22, these relays still go hot. So you have to power down the safety scanner and this, and the safety relay. If you don't, you can still activate the safety relay, and basically what we're trying to prevent is backfeed. So this relay here, it controls the power to both the safety relay and the safety scanner. This relay controls and bypasses the signals. So signals, power to the safety, and LED status lights. And again, like I said, if we don't have any power to this unit whatsoever, nothing will work. So there's definitely going to be it's a proper safety setup. So I made this myself. Took a couple of trial and errors just with small things, but worked out pretty well. So it's a mess right now, but we'll get it cleaned up and get her going. So for now, that's about it. So we're all set. Everything's nicely terminated with ferrules and things like that. And this is not flipped right, so I'll just take care of that at some point. But this is just kind of bench test completed, and then we'll get all the neatness done to it. There's a switch, so have it set up like so. Power jumper here, outputs here. So literally we have one going to a light and then one going in here. This is all jumpered, so this comes out and powers the coils. That's it. So pretty simple. Gives you a nice little option for a bypass if you can't use an e-stop. So we're using a Phoenix contact safety relay, a little bit less expensive, and they actually work really well. But make sure when you're doing any safety stuff that you bench test, check, double check all situations that you can. But in any event that any of these contacts for some reason weld together, it's 24 volts DC. You'll be in a failure bypass mode. So hope this helps somebody out. Thanks. Bye.